Hey everybody, we are going to continue to work on 9.2 notes. Oh, oops, wrong button. Okay, there you go. Okay, so I want to talk about planes and yes. Okay.
You asked me to unmute.
Oh, I did it again where I meant to actually mute. Just hearing some sounds. Let me see. I think I hit the wrong button. Okay, sorry about that. We have a plane which looks like ax plus by plus cz equals d. Okay. And we're in 3D, so you can have at most 3 intercepts, an x-intercept, a y-intercept, or z-intercept. Okay. X-intercept, you put y equal to 0 and z equal to 0. Okay, for the y-intercept, the other variables are equal to 0. So we've got x equal to 0, z is 0. Okay, last one, z-intercept has x as 0 and y as 0. Then let's talk about having one intercept. Well, let's see. Oh, by the way. Okay. First, we're going to say that a plane has less than 3 intercepts when one or more of the coefficients equals 0. So I made this mistake last time, and I thought the variable was 0, but it's the coefficient that's 0. So we're going to practice like general planes, and then we're going to redo the plane that we had at the end of last class. So let's see. First, planes that have one intercept. Let's go with, there's going to be three kinds. The first one is ax equal to d. So your coefficients for, well, we should put the general equation and then the coefficients. So the equation is ax plus by plus cz equals d. That means the coefficient b and that coefficient c, those are equal to 0. So in the shift, we have two coefficients that are equal to 0, b and c. Okay. We want to write that this plane is parallel to the xy plane. We're talking about this piece here. So this is the plane for this problem. Here's the general equation. And, we have to consider just the part ax equal to d. So we have to have b as 0 and c as 0. So let's talk about the graph. Okay, it's the set of all points x, y, z. And that's such that, let's see, we could have ax equal to d. Let's just write it like that. Ax equals d. Y and z are any real number. So we put y comma z exists in the real numbers. Close this up. Okay, so we have this ax equals d. Y is in the real numbers, z is in the real numbers. Cool. This is my z-axis. This will be x. And y. Okay, let's put, I think I put the intercept as the main point to plot. So this would be called the x-intercept. Where y equals 0, c equals 0. And x equals a over d. So we go to the x-axis to, let's call it positive a over d. Over here. And then that's my x. Y is 0. Z is 0. And the point is right there. So that's the x-intercept. And our plane, we're going to use that point and use the z-axis And from here, z can be any number positive or down to negative infinity. So we're going to go with a line that's parallel to the z-axis. Okay, and y can be any number. So go to the y-axis. Let's start back at that intercept and make a line parallel to the y-axis. And then let's say for this value y over here, we can have in that x value, this y value, whatever it is, z can be any number. So you're going to go parallel to the z-axis. Let's see. Last one, we're going to kind of finish the plane by drawing a line parallel to the y-axis somewhere up here. And then clean the sketch a little, like finish this as maybe a square. I think it helps to do a little like cross hatching, so lines going along the y-axis, like parallel to the y-axis, some parallel to the z-axis. That's my plane. And again, there's my intercept. Okay, we are going to do the plane by equal to d. Okay, this one, well, I'll let the graph sit here for a sec, but this plane is parallel to the xz plane. Let's go back to the previous problem. The previous problem, we had a plane, this one. This plane is parallel to the YZ plane. So the YZ plane is kind of sitting here like so this is my plane. And it's sitting on the XY axis, but just pulled out a bit this way. The other one, we have a graph and a sketch. Okay, the graph is the set of all points x, y, z. Such that by equals d, x is any number and c is any number. And our other variables are real numbers, x and c, existing reals. Let's talk about the y-intercept. We let x equals 0, c equals 0. That doesn't affect this equation. You get, when that occurs, y equals d over b. So the point we're going to plot is xyz 0 d over v 0. Cool. How do we make the graph? Okay, just let this sit here for a second so that way you can make space to draw a good picture. Okay, I think we're ready. So again, the intercept is 0, d over b, 0. Okay, 0 for x. So we're just going to go right here on the x-axis. Y, we're going to say this is a positive d over b for y. So let's go this way. Call that d over b. And then as far as z goes, we're going to go to 0 for z. So this point is 0. Let's go with the y-intercept, and from that point, z can be any number. So let's go up and down, parallel to the z-axis. Also, let's go from this place. Let me see a sketch. So we went from that intercept and let x be any number. So from here, let's just go this way, parallel to the x-axis. Okay, let's stop about here and say for this y and for this x, z can be any number. Just let z go up and down. And then let's go here, let's see. For this y value and some x value. Out this way for y and over this way for x. Wait, let me think. Out this way for y. And let's go up here for z. And then let x be any number. Okay, so it's a good start. We're going to represent this plane by drawing a square. So we're going to clean the corners. I'm going to do a bit of cross-hatching. And just remember that this one is parallel to the xz plane. So xz is sitting like z up and down, and x is tilted this way, and then you bring your plane just out a bit, and then pop it out away from there, this way. Let's see, that way, away from the xz plane. Okay, so let's go with x this way. Z up and down. And again, that was a y-intercept. And there's one more with the z-intercept. Last one, the plane CZ equal to D is parallel to the XY plane. let's look at the graph. Okay, the graph is a set. It's a set of all points x, y, z. Such that this happens, cz equals d, y and x are any real number. Y, comma, x then exists in real numbers. This is double bar, r. So one more time, cz equals d and, apostrophe, y comma x exists in the reals. Let's actually put square and talk about the z-intercept. You have y equal to 0, x equal to 0, which doesn't have any effect on this here. So when that happens, you still have z equal to d over c. So we have a 0 for x, a 0 for y, d over c is z. Okay, so again, I'm just gonna let this sit here. So if you're copying this down in notes, that's your z-intercept. And then we draw a graph. Or we draw a sketch of the graph. Okay. So leave a point sitting there. Get your x-axis, y-axis. It helps to start here and then go up for z. And plot this point first. 0 for x, so here. 0 for y, there. Up, d over c. That's good. Okay, that's a z-intercept. So let's start here, and y can be any number. So use the y-axis and draw a parallel line. This way for y and that way for y. Okay. Let's stick with this intercept, and x can be any real number. So from here, use the x-axis and go like back and forth. Maybe a little more tilted. Okay, cool. And we've got this value z and some value for x. And then let's say here, and y can be any, let's see, y can be any number. Actually, the y-axis is here, so we're gonna go like this, parallel to the y-axis. Okay, last part is, let's go somewhere. Like this is my z. Z has to equal d over c. this, so that's my z, and this way for y, and let's call it like here, that x can be any number. Let's go further. Let's go over here. C is C over D. Y is something over here. And X can go this way through the real numbers or back. So use the x-axis to make a line that's kind of parallel to it. I'm going to use this square as the plane. So clean up the corners. Cross-hatching, again, x is any number, so we're going to use the x-axis and make lines parallel. And y is any real number, so go to the y-axis and make lines parallel to it. So this one is kind of like the xy plane is sitting flat, and you take this plane and lift it up along the z-axis a certain height. Okay, let's see, I have more about planes. Cool. So these planes are going to have two intercepts. So there's ones with xy intercepts. This one's going to look like ax plus by equals c. This is parallel to the z-axis. We've already covered how to find the x and y intercepts. I might do it just once for this graph, but from now on, I'm just going to tell you what they are and use them as part of our sketch. So let's do this one. The z-intercept, the x-intercept and the y-intercept. Y is 0 and z equals 0. So if we go over here and put y equal to 0, this disappears. We have ax equal to d, which means x equals d over a. Okay. The y-intercept. As x as 0, z is 0. And then let's just put that in here. There's a 0 for x. We get by equal to d. So for this one, y equals d over b. All right, the graph. So we just have to have this rule in there, and we can let x be, x is in there, y is in there, z is any number, any real number for that missing variable. We need x's, y's, and z's such that, I lost it, ax plus by equals d. And Z is in the real numbers. Okay, so we're going to plot these points. It goes X, Y, Z, X, Y, Z. Oh, my Y. On the side. D over A, 0, 0. We also want 0, D over B, 0. All right, so we need our X, Y, Z axis, and then we're going to get those two intercepts somewhere on there. X, Y, Z. Okay, we need D over A on the x-axis. 0 for Y, 0 for Z. Cool. Then plot 0, D over B, 0. 0 for X gets you right here. D over B. And then 0 for Z. So your dot's right there on the y-axis. Cool. So this is kind of like the problem we did last time, which we are going to redo if there's time. So first connects the intercepts. Let's go to this intercept. So from here, Z is any real number. So use that Z axis and go parallel to it. Let's just go up from here. Just a bit. All right, from this intercept, Z can be any number. So we'll also from here, go parallel to the Z axis. And we're going to copy this line up here. So I'm going to try to draw, let me see, a line parallel to that line. Shift straight up and draw. All right, and then the book uses some dotted lines to show you that this plane is parallel to the Z axis. So I'm drawing a line parallel to this one. I'm going to put little dots to the Z axis and a line parallel to that one coming in. Little dots come back in. And then I put up and down lines, so Z can be any number going up and down. Okay, next one is the plane. AX plus C, C equals D. This one is parallel to the y-axis. we'll draw the graph, or let's write the graph as the set of x, y, z such that ax plus cz equals d. And you could put the word and, but I feel like apostrophe is fine. Cool. Ax plus cz equal to d doesn't say anything about y. So y is any real number. Y exists in the reals. Close your set. We're going to just go ahead and sketch a graph. So this one looks like it's kind of tilted. I'm going to write, and we'll just plot and write the intercepts. The x-intercept is d over a, 0, 0. The z-intercept would be d over c for z, and x and y are 0. So 0, 0, d over c, which is on the x-axis. Okay, to draw these planes, connect those intercepts. We're going to use this intercept and let y be any number. So we'll go parallel to the y-axis. You can go in both directions, but I'm going to go just this way. From this intercept, we can also let y be any number, so we're going to go parallel to the y-axis from that point as best as you can. And then, let's see, x is this value. We've picked some number y, and from here, z can be, actually no, from here, we want to copy this line. So we want to have this line parallel, right, between those lines. So I'm going to get an edge. Take this line over here and just draw it. Cool. So let's do some sketching. We're going to make copies of that line over to the one that I just drew. So parallel to this. And then from the picture in the book, it helps to show that this plane is parallel to the y-axis by doing dotted lines from here to here, and here to here. Maybe like it's supposed to be straight up and down. Something better. It looks okay. So it's tilted and away from the y-axis. This one. And I think we're at the last one that has two intercepts. Yep. This plane is by plus cz equals d. By at c. Okay, this one's parallel to the x-axis. So let's write the graph. I'm just going to skip it, but it's important. So the graph would be all triplets, not pairs. We need an x and a y and a z, such that by plus cz equals d. And x is any real number. X exists in the reals. So we're going to graph this plane. Go in with this as z. Here's going to be x. This is x. This way is my x. Okay, we want to plot 0, 0, d over c. Right here. That's a z-intercept. X is 0, y is 0. Z would equal d over c. Okay. We also have a y-intercept when x equals 0 and z equals 0, and y would equal d over b. That was 0 for x and 0 for z. Then connect your intercepts to get a drawing of the plane. And let's use the intercepts. Let's go up here. At this intercept, x is any number, which I'm going to fix my x-axis a little bit. Pretty straight. Okay, so we want to start here, go parallel to the x-axis. This way. A little more. Okay, looks okay. Let's use our other intercept and take that one with a line parallel to the x-axis. So we're letting x be any number. Y is stuck at d over b. And z is 0. Cool. So let's go here when we have y equal to d over b, z equal to 0. No, sorry, y equals d over b. Let's go x is some number this way in the positive direction. Actually, we're not going anywhere for z. We have to follow this rule. So we want to copy that line. Let's get a copy of this, shift it over here, and just drop this edge. All right, I'm gonna clean up the corners. Let's draw copies of that line. So we're going parallel to that edge. That's my plane. Last little part is to draw some dotted lines that show that this one is parallel to that x-axis. So from the x-axis, we've taken this plane out that way. So we're going to go straight down here and then over there. Okay, let's call that good. Thank you for coming to class. We are just going to keep